Okay, we are going to look at cryptography, the art of writing or coding not in computer codes, but just in writing messages and things like that. So this will be a real quick video. I just want to kind of walk you through how you work this out. Okay, first of all, we're going to set up our messages using a standard encryption method, right? We're going to let A be 1, 2 be B, all the way to Z equal to 26, and we're going to let this space, all right, equal 0. Right? So I'm going to kind of take you from the beginning all the way through of encoding a message and then going backwards and decoding it. The really important part for you is to learn how to decode a certain message, right? Right? So what we're going to do is I've got a message. Bow ties are cool, right? So we have this message right here. What I'd like to do is I'd like to encode this message. We have decided to use this matrix as my cipher, as my lock, as my key. Okay. So what that does is that makes me stick to a n by 3 matrix. Whatever I do, because my cipher is a 3 by 3, I have to have I have to have 3 columns in my messages, right? So what we've done is you'll write out your message, and then you're going to write just above or below those numbers, you're going to write, or those letters, you're going to write the numbers that correspond to the letters, right? So my message is bow ties are cool. So B is the letter 2, O is the letter 15, W is the letter 23. So that's where you're going to get 2, 15, and 23 from, right? They correspond to those. So you write your message out like this, and then above each one or below, you're going to write the corresponding numbers. What that does is that creates your uncoded matrix, right? So that's, you're going to see that here. And you're just grouping them in 3s. In this way, you're going to kind of keep going through here. Okay, so bow ties is the first word, right? And so you see that letter here, then you have a space, which is 0, and then you have R, which is the second word, then space, and you have cool, and then you have 2 extra letters or numbers in that last matrix. Remember, we have to have a 3-column matrix. No matter how many spaces you have left over, you're going to have to fill those spaces with zeros, right? So I had 1 letter left to go into the last row, so I had to fill the extra 2 positions with the number 0 to represent the spaces. Okay, we don't have punctuations here, so we're really assuming you're just going to write 1 statement. You don't want to make this too long anyway. So what happens next is we have to have what's called a cipher. We have to have a matrix that can encode my message so that if someone were to get it, you couldn't just simply translate these numbers back into letters, right? We're using a pretty easy way. You would naturally think, well, let's let A be the first one, B be the second one. And so if you were to switch it back, that would be pretty easy to do. So what I'm going to do is I'm going to create an equation so that we're going to change my numbers from the original numbers that correspond to letters into other numbers that don't necessarily correspond to anything. And if someone were to get your encoded matrix, this one right here, they would have a very difficult time uncoding it or decoding it back into the original statement without having your cipher. So here's what happens. We're going to, and I'm using the calculator to do this. The uncoded matrix, B, is going to be here, and I'm going to have to multiply B times cipher A. Okay, so we're using B times A, and we're going to get this result here. And that creates a very large matrix, but it's exact same size as the previous matrix, right? It's got 3 columns, it has 6 rows, but the numbers don't necessarily correspond to anything normally that we're used to seeing with letters. Okay, so normally what would happen is you would send this message out to whoever you're trying to get a message to. If someone were to intercept that message, they would have a very difficult time decoding your message. Okay, how do you decode a message? Well, you basically do what we just done backwards. Okay, so here we have a coded matrix. So you're really going to be doing, this is going to be the matrix that's where you have your coded message in. You're going to multiply times the cipher inverse. Now, let's be clear, my cipher that I'm using is this one. I wrote down the inverse here, but I don't really want you to put this into a matrix. We're going to keep this cipher in your matrix A. When you multiply, really it's going to be this kind of right here. It's CA inverse, right? So it's C. For me, C is my coded message. That letter can be different for you, times the cipher inverse. So if we really think about it, it really is more about the coded message times the cipher inverse. That's going to be equal to your uncoded message. What that means is I would have to do that kind of multiplication and to turn it back into that. So what we do is you have your message here that's been coded times the inverse of your cipher, and that's going to turn it back into what we can translate in our original message, where A is 1, B is 2, and so forth, back into our original message. Okay? And so here's one for you to try. Now remember, we're going to group these into 3, so I need to create that first matrix. I need to create this matrix right here. Okay? What we're going to do is we're going to create groups of 3. So that's your first line. This will be your second line. This will be your third line. And then this will be your fourth line. So you end up getting a matrix that is a 4 by 3, 4 rows by 3 columns. I'm going to use the exact same cipher, so I'm using this matrix as my cipher. What we're going to do is we're going to do whatever you put this matrix into, right? All of these numbers at the bottom down here. Put those, I think I put mine into matrix B. And then I'm going to do B times the cipher inverse. I have my cipher in A, so I did B times A inverse. And I'm going to get a message at the end, right? You should get Dr. Who. That should be your message if you work it out correctly, and that would be good to go. Hopefully that was not too crazy complicated. Be careful on how you work these things out. Most of the time people have a problem with this is usually because you type something in wrong and you got a sign wrong, just one wrong sign, one wrong number, and it won't work out. So be careful, go slow. This is relatively easy to do, but really easy to mess up as well, because there's lots of places for you to just make a careless mistake. Okay? Hopefully this will help you. You will definitely have to do this, and you're going to need this little square here to translate the message on the concept checked as well. So make sure you have this up when you do that. If you don't have a calculator, you can always search online. The Desmos calculator, I don't believe, will do a very large matrix, but there are other ones out there, I suppose. Maybe not, I'm not sure. If you run into a problem with a calculator not being able to do it, then let me know, and I will see what I can do to help out. And there it is. I'll see what I can do to help out. Okay, let me know if you have any questions. Otherwise, have a good day. And then remember we have a test on Friday. Make sure that you spend some time studying over this stuff on Wednesday and Thursday. This should be a pretty straightforward test, a good opportunity to make a really good grade. So if there's any questions, please let me know, and I'll be glad to help out.